Hi again, Graham. I've got number 25 here on the screen, and we're going to go through the same steps that I showed you, and I realize this one's different because it's got a ln function in it. So let's deal with the derivative first and foremost. We've got x squared, and we're going to take the derivative of that and get 2x. Now the derivative of ln x is 1 over x, so if we have 8 of them, it's just 8 over x. Okay. So if we set that equal to 0, the way that we would normally find our max and mins, then we can solve this by taking 8 over x to the other side. We have 2x squared equals 8. X squared equals 4. Now we're going to get two roots. Don't forget, when we take the square root, we get plus or minus 2. Okay? So, because the interval they gave us this time is 1, 4, we have to toss out the x equals minus 2 root because it's not in the interval. Okay, so we just need the x. I'm trying to do a therefore symbol and I'm making a mess of it there. I'm just going to do x equals 2 from the zeros that I found from the first derivative. And then the other two values are these guys that we're going to test on the left and right boundaries of our interval. Okay. So what we're going to do is set it up the way we did on the previous slide that I made you. And we need to test f at 1, f at 2, and f at 4 to see who's the winner. We need the lowest value of y and the highest value of y for our absolute extrema. So when you're evaluating a ln function, I'll just go through the first one for you here. 8 times ln of 1. If it's ln of 1, that means that I have e to some exponent and I get an answer of 1. So the only thing that's possible there is if x is equal to 0, because anything to the exponent 0 equals 1. And so that basically just makes that whole thing 8 times 0 or 0, so it's just equal to 1 there. So same idea here, you're going to have to use your calculator because when you get into ln of 2 or ln of 4, you're just going to have to punch those into the calculator and get a decimal answer there. Let me see if I can come up with something here. I think I get a negative here, 1.5 I wrote, and this one comes out to about 14.6, I think. So in terms of the relative, or sorry, not the relative, the absolute extrema, then your absolute min is going to occur here when x equals 2 and y equals negative 1.5, and your absolute max is going to occur when x equals 4 and y equals 14.6. Okay. For number 27, when I blow up the picture that you sent me, it's a little fuzzy, and I think it says e to the negative 3x. So I'm going to go with that, and if I'm wrong, hopefully you can just follow my instructions and redo the question if I have that wrong exponent, okay? So finding the derivative here is going to be a little bit tricky to begin with, and this is a good one for us to do because you had asked earlier about differentiating e to the x. So if we have the derivative of this function, the derivative of the x is just 1, so that was easy. And the derivative of e to the negative 3x is e to the negative 3x times negative 3. That's the chain rule part of it, okay? So if I put that in front, we would usually write the derivative like that. So setting this derivative equal to 0, we're going to try to solve for x here. And so if I move 3e to the negative 3x over to the left side, I'm going to divide both sides by 3. And what we have to do now is take the lns of both sides, I think. I'm trying to see if there's another way to do this. Oh. A negative exponent means the reciprocal of the positive exponent. So one way to look at this is to write it like that, which means if 1 equals 1 in the top, in the numerator, then e to the 3x has to equal 3 in the denominator. So, okay, I think we still have to use logs here to do this. So what we're going to do is we're going to multiply the 3x in front and take the ln of e. And then we're going to take the ln of 3 on the other side. Okay? So the ln of e is just 1. So we have 3x times 1 equals the ln of 3, or x is equal to the ln of 3 over 3. And what I would do is just leave it there, although I guess we need to know if that value is within the range negative 1 to 3 in the interval that they gave you. So I'm going to work that out and put you on pause for a minute. Okay, so that actually is in between negative 1 and 3 is 0.336, or sorry, 0.3662. I know I'm tired tonight. So you would have to go back into the original function with these 3 values. And work out again which one gives you the highest y value, which one gives you the lowest y value, and that's your absolute max and min. So I hope that helps, and we can maybe talk a bit more on Thursday, and maybe help with some of these strange ones like the e to the x and things like that.